Welcome to Text-to-Text Prompt Techniques. After watching this video, you'll be able to describe the techniques using which text prompts can improve the reliability of large language models. You'll also be able to explain the benefits of using text prompts with large language models effectively. In recent years, there has been a significant advancement in natural language processing, or NLP, by using large language models, or LLMs. However, as the size and complexity of LLMs continue to increase, questions about their reliability, security, and potential biases have surfaced. Using text prompts effectively is a promising solution to these concerns. Text prompts are carefully crafted instructions that direct LLM behavior to generate a desired output. However, the quality and relevance of the generated output depend on the effectiveness of the prompt and the capability of the LLM. Let's explore the techniques that make text prompts effective and improve the reliability of output generated by LLMs. Let's begin by exploring the task specification technique. Text prompts should explicitly specify the objective to the LLM to increase accurate responses. For example, the prompt "translate this English sentence into French" is a clear directive for achieving the task. Contextual guidance is a technique using which text prompts provide specific instructions to the LLMs to generate relevant output. For example, if you'd like the model to generate a short write-up on the landmarks of New York City, a prompt like "write a short paragraph on New York City" would yield a generic response that might not cover what you want. On the other hand, a more specific prompt like "write a short paragraph on New York City," highlighting its iconic landmarks, would generate a more appropriate output because of the context included in the prompt. Domain expertise is also essential to improving LLM dependability. Text prompts can use domain-specific terminology when you need LLMs to generate content in specialized fields like medicine, law, or engineering, where accuracy and precision are crucial. Let's say you'd like to request medical information regarding hypothyroidism. Your prompt could read something like, "Please explain the causes, symptoms, and treatments of hypothyroidism, including the latest research and medical guidelines." Bias mitigation is a technique in which text prompts provide explicit instructions to generate neutral responses. For instance, let's assume that you are concerned about a gender bias in the model's response to a prompt for a write-up on leadership qualities. To address this, you can use a text prompt like this: "Write a 100-word paragraph on leadership traits without favoring any gender. Provide equal examples of traits from all genders." Framing is yet another technique by which text prompts guide LLMs to generate responses within required boundaries. Suppose you'd like the model to summarize a lengthy article about climate change. Your text prompt can be, "Provide a summary of 100 words of the article on climate change, focusing on its primary findings and recommendations." Did you know that LLMs today, trained on large amounts of data and tuned to follow instructions, can perform tasks zero-shot? Zero-shot prompting is a method using which generative AI models generate meaningful responses to prompts without needing prior training on these specific prompts. For example, the prompt could be, "Select the adjective in this sentence." The sentence is, "Anita bakes the best cakes in the neighborhood." The output here would be "best." However, often you will not get the desired response in one prompt, and you may need to iterate. This is where the user feedback loop technique comes in, wherein users provide feedback to text prompts and iteratively refine them based on the response generated by the LLM. This loop allows users to improve the model's output quality incrementally until the desired state is achieved. For example, the user asks the model to write a poem via a text prompt. The LLM generates a poem. The user says, "Make it more humorous." The LLM adjusts the poem to include more humorous elements. The user approves the revised poem. Similarly, for complex tasks, when you are unable to describe your needs clearly, a technique called a few-shot is used. It enables in-context learning, wherein demonstrations are provided in the prompt to steer the model to better performance. The demonstrations act as conditioning for subsequent examples where you would like the model to generate a response. For instance, suppose the task for the model is to generate short travel recommendations. As few-shot prompts, you provide the following guided context to the model. Recommend a summer travel destination well known for beautiful beaches. Suggest a fall travel destination that is renowned for its beautiful foliage. After using these few-shot prompts, the model can generate travel recommendations for other types of vacations. For example, if the task is "recommend a city to explore," the model will generate an answer: "Consider visiting a vibrant city like Paris, known for its rich history, art, and iconic landmarks." This is how the model can generate travel recommendations for different types of vacations based on the minimal training data provided in the few-shot prompts. There are several benefits when you use text prompts with LLMs using the methods we just discussed. Let's look at some of them. The LLM's explainability is enhanced. Explainability refers to the degree to which a user can understand and interpret the model's decision-making process and the reasons behind its generated outputs. Explainability helps users, developers, and stakeholders understand how the model works, why it makes certain predictions or generates specific text, and whether it can be trusted in various applications. Explainability is crucial to addressing ethical concerns related to AI. It helps all stakeholders evaluate and ensure the LLM's behavior is consistent with a specific domain's ethical guidelines and legal requirements. In addition to increasing the reliability and explainability of LLMs, effective text prompts also foster trust between the user and the LLM. When the user can understand how the LLM works and see the direct influence of their instructions on the LLM's behavior, it leads to transparent and meaningful interactions between the user and the LLM. In this video, you learned the various techniques using which text prompts can improve the reliability and quality of LLMs. Specifically, you looked at task specification, contextual guidance, domain expertise, bias mitigation, framing, and the user feedback loop. You also learned about the zero-shot and few-shot techniques. Finally, you learned the several benefits of using text prompts with LLMs effectively, such as increasing the explainability of LLMs, addressing ethical considerations, and building user trust.